Hello everybody, this is Mr. Kusaj, and this is lesson 3-3, properties of logarithms. Don't forget the date over here. So now we want to look at more facts about properties. And before we do that, do you remember the exponent rules? Remember when you multiply, you add the powers, remember that? When you divide, you subtract the powers, remember that? And then when it's like power, then you multiply. Very similar rules in logarithms. So let's look at the properties. First one is, if you have log of xy, log of something times something, then you can take the log of the first, log of the second, and add them. Okay, so log of xy is equal to log x plus log y. And this will make sense. Log of x divided by y is equal to log of x minus log of y. Okay. This third one we're going to use a lot to solve equations with log in them. Look what happens here. If you have log of something, of a number or a letter, and it has a power, then you can bring that power down to the front and make it a regular number. Okay? Make sure you get this one for sure. Because these one kind of make sense because they remind you of the other properties, the old properties. But this one is a little different. So, again, if you have x to some power p, the p comes down to the front. And now there's nothing there. It came to the front here. Okay? And these same properties hold for natural log. Same exact properties. Just replace log with ln and you got the same properties. Okay. So let's look at some examples. One way to ask questions that force you to use the properties is to express a given number in prime, with prime numbers, 2s and 3s. So express ln of 54 with just 2s and 3s. What does that mean? Well, you know that 54 is what? 9 times 6, right? So maybe it's ln 9 times 6. Oh, how about ln of 2 times 27? Because we're looking for 2s and 3s. Okay, but that 27 is not a 2 or a 3. But we can express the 27 as 3 to the third power. So now if you look, the 54 becomes 2s and 3s. 54 is 2 times 3 to the third. Okay, now I can rewrite this using my properties. What do I do when it's multiplication? What do I do when it's multiplication? Right? It's going to be ln 2 plus ln 3 to the third. ln 2 plus ln 3 to the third. And what does the property say? The third one here, what does it say when you have a power? Comes down to the front. So there you go. I have expressed ln 54 with 2s and 3s. Okay? How about the second example here? Natural log, ln, natural log of 9 over 8. Well, if we use the property, it's ln 9 minus ln 8. Right? That's what the property says. When you divide, you subtract. Well, we know 9 is 3 squared, and 8 is 2 to the third power. Remember, we're trying to express in 2s and 3s. And then we used the, again, the third property to bring the 2 down and the powers. You bring the powers down to the front, and there you go. I'm done. I expressed ln 9 over 8 with 2s and 3s. There you go. Okay? So simplifying log base 4 of fifth root of 64. Now what you need to know for this is, we talked about this once before, but I'll remind you. Square root of x equals x to the half, right? Do you remember this? Cube root of x is equal to x to the 1/3. Fifth root of x is equal to x to the 1/5. Okay, we can express it this way. So it helps us because our properties don't involve the square root. But if I change it to this, now I have a power here, and our properties, right? Our properties work with powers. So what else can I do here? 64 to the 1/5. Well, you know 64 is 4 to the 3rd. What you're trying to do is match. Remember, match this number with this number, because then it'll cancel, right? So I was looking for a 4 here, not a 2, right? Not an 8. I was looking for a 4 here because it'll match this 4, right? So you multiply power times power, so 3 times 1/5 is 3/5, right? Then what? Now the 3/5 comes to the front, right? The power comes to the front, and 4 to what power is 4? In other words, this cancels. It's 1. Remember in 3-2, whenever these numbers match, this whole thing cancels. You're left with 3/5. Done. So I have simplified this. So what we learned from this example is, if you do get a root symbol, turn it into a fraction power. Yes? How about this one? 5 ln e squared minus ln e to the 3rd. Well, if we use the properties, the 2 comes down here, the 3 comes down here. So that's how I got this. Right? So this is 10, this is 3. Now what do you know about ln of e? Right? If you go back to 3-2, we talked about how those cancel. That equals to 1. They cancel. Whenever ln is next to the e, they cancel. So really, you just left with 10 minus 3, which is 7. Okay? I'm using the properties from this section, and once in a while, a property from the previous section, 3-2. Okay? Another way we can use the properties is to simply ask you to expand or condense. So here is an expression, and it has log in it. It says log of 12 times x to the 5th times y to the negative 2. Right? So we want to expand it using the properties. Well, whenever we have multiplication, we know that means adding, right? So log 12 plus log x to the 5th plus log y to the negative 2. That's what I did. Now I look at each one of those, and I have another property that says whenever you have a power, it can come out to the front. So I'm going to bring these powers to the front, like that. The 5 comes here, there it is. The negative 2 comes here, there it is. I'm done. What did I do? I expanded, right? This was condensed in expression, and I used the properties to expand it. And then you can do it the other way. You can condense it. So this is already expanded. Let's condense it. Well, first of all, these numbers here, right, can go back to being powers, right? The 1/3 can go back to being powers, right? So that's how I got this, right? Now what? Minus comes from the division of this and this, right? Oh, before we get to it, notice that I changed this back to a radical sign because it's easier to see and it looks better. You don't absolutely have to. So this comes from division, so it's going to be log, and then this divided by this, right? Log of x to the fourth. Now, they're all base 3, so I'm not going to keep saying base 3. Log of x to the fourth, log of this expression, right? They're divided. So think of it this way. What does this mean with our properties? It means log of this minus log of that, right? So now we're going backwards. We're going backwards, all right? So why don't you try a couple of problems. Try these two problems. Try expanding this problem. I'll tell you right now, this is division, so there's a minus involved. Try condensing this problem. I'll tell you right now, this is plus, so there's multiplication involved. Okay? All right. The last thing I want to mention is, do you remember when we talked about how if you have on the calculator, you can only work with base 10. So if you have some base that's not 10, you can't enter it in the calculator, right? They're inconvenient. I call them inconvenient because you can't use the calculator. Well, there's a rule that helps you with any base you have, helps you to change it to just base 10 or common log or natural log, right? And these we can do in the calculator. This we can't. So here's the rule. Log base b of x is the same thing as common log of x over common log of b. So the way I remember it is, this number is a little higher, written a little higher above than this number. So it's going to be log of this over log of that. And it works the same way for ln. So you can change this to this or change this to this. It doesn't matter. You're going to get the same answer. So let's look at some examples. Okay. So again, getting back to inconvenient, log base 3 of fifth, what it's asking us is 3 to what power is 5? 3 to the 1 is 3. 3 to the second is 9. So it's 3 to the 1 point something. But how in the world are you supposed to do that? Calculator. Well, how do you enter this in the calculator? You can't, right? It doesn't allow us to put some strange base here. We only have common logs, right? Which means base 10. So this rule allows us to change this to this, right? Log 5 over log 3. See, the base is gone, which means it's base 10, which means common log. In other words, just use the calculator and put what you see on the screen and you'll get the answer, right? So log base 7 of 11 means 7 to what power will give you 11. 7 squared is 49, so again it's 7 to 1 point something, right? So again, we don't know what it is, can't use a calculator, so we use this rule and change it to common logs. This is the change of base rule, right? Here we have base 7, here we have base 10, base 10. We change the base to a base that the calculator can do. So how do you write it? Log of 7 goes in the bottom, log of 11 goes on top. Do the division, trust me, it comes out to 123. Oh, I guess I thought this was so simple that I didn't put a try problem here. Anyway, we'll do more in class. I do not believe there's any more to this section. There is no part 2. So 14 minutes, but there is no part 2. So I guess that's good news. All right, see you in class. Bye.